Hello students, welcome to my next video tutorial, and in this video we are going to learn the scattering of light, and we will be having the answers of various questions like why the color of our sky is blue in the daytime and why the color of our sky is reddish orange during sunrise or sunset. So these all questions answers we are going to find out in this video. Okay, so scattering of light. So before going to scattering of light, let's see what is dispersion of light. That was the splitting of white light into its 7 different colors after falling in a prism or some denser medium, right? The prism is we considered as a denser medium which refracts the ray of light, and white light is being splitted up into 7 different colors, and these 7 colors they have different wavelength, so they deviate with different angles, so which we have already learned in our previous video, right? So what is scattering of light? So scattering of light is the phenomena in which there is a change in the propagation of light. This is due to the number of minute particles in the atmosphere like smoke, water droplets and many other. We know that in our atmosphere there are heterogeneous mixture of fine particles. So whenever a sunlight passes through the atmosphere, it gets collide with the fine particles. Now after collision, what happens? These fine particles they absorb the incident light and they get re-emitted after reflection with these fine particles, right? So you see, so whenever a light falls on the fine particles and it again gets reflected, the intensity gets diffuse. So and this results in the color which we perceive by us. So the color after scattering which is perceived by us depends upon the size of the particles. Okay, so this scattering of light is being observed by a scientist called Rayleigh, and he has named it as Rayleigh scattering. So according to Rayleigh scattering, it states that the scattered incident light is inversely proportional to the fourth power of wavelength. So let's see what it is. This is the incident scattered light. Okay, which is inversely proportional to fourth power of wavelength. So this says that the light which has longest wavelength will be scattered least, and the light which has less wavelength will be scattered most. So what is actually the scattering of light here? It is the phenomena in which there is a change in propagation of light. This is due to the collision with the fine particles, that is water droplets, smoke and other suspended particles in the atmosphere. Okay, so this is the definition of scattering of light. So due to this, what happens? The scattered light depends upon the size of the particles. If the size of the particles is very small, very fine, very minute, then the scattered light will be blue in color. Similarly, if the particles in the atmosphere is become larger, then it will be due to that longer wavelength. So the more longer wavelength will get reflected by the larger particles. Now if the particles are big enough, then you see this reflected light will be in color of white. So the size of the particles in the atmosphere determines the color seen by us. That means the color which we see by us means which we see, that means that depends upon the size of the particles in the atmosphere. Okay, so this was a Rayleigh scattering, that is incident scattered light is inversely proportional to fourth power of wavelength. So for better understanding, I wrote the definition on the board. You see, the phenomena of change in the direction of propagation of light caused by a large number of particles such as smoke, water droplets, suspended particles in air, etc. is called scattering of light. And the color of the scattered light perceived by us, that means with which color is seen by us, it depends upon the size of the particles in the atmosphere, because the atmosphere of Earth is a heterogeneous mixture of fine particles, right? So very fine particles is scattered mainly the blue color. That means the blue color is being seen due to fine particles in the atmosphere. Bigger particles scatter light of longer wavelength. That means if the light is of having a longer wavelength, that means that will be scattered by the bigger particles. Similarly, a white light gets scattered by the larger particles. Okay, so these 3 points you need to remember. And Rayleigh scattering. So according to Rayleigh, the intensity of scattered light is inversely proportional to the fourth power of wavelength of light, that is I, inversely proportional to 1 by lambda to the power 4. So the most asked question, why the color of our sky is blue? The reason is that the average size of the particles in the atmosphere is very small as compared to the wavelength of visible light. So as the size of the particles are very small, and when the sunlight passes through these particles, so you see it allows the shorter wavelength and it scatters less for the longer wavelength of light. So the reason here I have written the average size of the particles in the Earth's atmosphere is smaller than the wavelength of visible light. These particles are more effective in scattering light of shorter wavelength. That means the average size of the particle is very small, and these small particles are able to scatter only the light of shorter wavelength, that is at blue end. That means when I say at blue end, that means violet, indigo, blue. So these are the colors, and it does not scatter much for the light for the red end, that means red color and orange color, right? So thus when the sunlight passes through the atmosphere, fine particles in air scatters the blue more strongly than that of red color. Okay, so this is the main reason why the color of the sky is blue during the daytime. So the answer to this question, why the color of a sky is white at noon? At noon the sun is just overhead, and therefore light has to travel relatively a shorter distance. Thus most of the light reaches us without any scattering. This makes the sky appear blue. So that means during 12 o'clock, that means 12 p.m., the sun is just above the earth, that means that is just overhead, and light travels relatively shorter distance. It travels the smaller portion of the atmosphere, and thus without any scattering it makes a white color. Similarly, the color of clouds are also white. As you see, clouds which contain the dust particles and water droplets of bigger size are nearer to the surface of the earth. The dust particles and water droplets in the cloud scatter all the colors of light incident from the sun. Thus the light reaches the surface of earth as such that it makes the clouds appear white. So the next question, why the color of our sky is reddish orange during sunrise and sunset? That is the red color of the sun at sunrise and sunset. Easily understood from this diagram. You see, during sunrise or sunset, the sunlight travels through the maximum portion of the atmosphere. So when the position of our sun is very near to the surface of earth, that means that time the light travels through longer atmosphere, that means it covers more distance. Similarly, when sun is overhead at 12 p.m., it travels less portion of the atmosphere. So when it is at overhead at 12 p.m., it travels a low distance, that means a small distance in the atmosphere, so the color of a sky is that time white. But when the sun is very near to the horizon and it travels the larger distance, then it gets collided with the larger fine particles in the atmosphere. And we know red color scattered least because its wavelength is more from the Rayleigh scattering, that was I inversely proportional to 1 by lambda to the power 4. That means wavelength of red light is more, so scattering will be less, so it will be less scattered. Similarly, the blue color or the violet color, they will be scattering most because the wavelength is small. So they will reflect and scatter away from the horizon, making the atmosphere reddish orange. Okay, so this is the reason why the color of a sky is reddish orange during sunrise or sunset. The reason is that during sunrise or sunset, the position of our sun is very near to our earth, due to which the sunlight travels through larger portion of the atmosphere. So while passing through a larger portion of the atmosphere, it gets collide with the more fine particles, and due to which the longer wavelength light gets least scattered, whereas smaller wavelength of light scatters away from the horizon, which makes the color of our sky look reddish orange. So you can write from here also. You see the reason is given. During sunrise and sunset, the sun is near the horizon. Thus the rays of light have to travel a larger atmospheric distance. Therefore, the light comes across the more number of particles causes the scattering. As the wavelength of red light is the longest of all the colors of sunlight and it is least scattered, most of the blue and other colors are scattered away. Only the red color of wavelength enters into our eyes. Hence the sun appears reddish during the sunrise and sunset. So these two questions are very important. So you need to write these answers in your exercise book along with the diagram. So also you need to write the differences between the ultraviolet, visible and infrared radiation. In the previous class we have gone through spectrum. So there you have to write this note: ultraviolet, that is UV radiation, visible radiation and infrared radiation. So the range of wavelength is given. UV radiation, the wavelength ranges from 4000 angstrom to 10 angstrom. Visible light wavelength ranges from 7000 angstrom to 4000 angstrom, and infrared, that is 10 to the power 6 angstrom to 7000 angstrom. UV, they are invisible, visible light, they are visible, and infrared are also invisible. So out of these three radiation, UV produces heating effect, visible light radiation produces slight heating effect, and infrared radiation produces more heating effect, that is the highest of this radiation. Ultraviolet rays affect photographic plate, visible light, they affect photographic plates, but infrared light, they do not affect photographic plates. Similarly, UV, they show fluorescent on the zinc sulfide screen. Visible light, they cause no fluorescence. Similarly, infrared also cause no fluorescence. And UV radiation, they are harmful to the human body. Visible light, they are not harmful, and infrared, they are not harmful to the human body. That means only here UV radiations are harmful to the human body. Out of different radiations, some radiations you need to write in your exercise book, because maximum time from board the question comes from this topic. Infrared radiation, they might ask what are the sources of infrared radiation. All bodies containing heat such as sun, a heated iron ball, a flame are the sources of infrared. That means infrared means the object which gives us heat. That is the source of infrared, because infrared has a property of strongly heating effect. So the sun is the natural source of infrared radiation. Now how can you detect the infrared radiation? By blackened bulb thermometer, which shows a slow rise in the temperature when moved from violet towards the red end, but the temperature rises rapidly beyond the red region. It is also detected by the thermopile. That means that is due to the produce a small electric current. That means rise in temperature due to electric current. By a phototransistor. And next, our body detects infrared radiation by its heating effect. That means wherever you find the heating effect, you find that there is a emission of infrared radiation. And these are the properties. Infrared radiation are not affected by electric or magnetic field. They have longer wavelength between 1 millimeter to 7000 angstrom. They travel in a straight light because it is a electromagnetic wave, so the speed of light is same as that of infrared. They obey the laws of reflection and refraction. They produce heating effect. They scatter less by the atmosphere because of longer wavelength, so they can penetrate appreciably through it. That means this infrared radiation, they have longer wavelength, and just now we have learned if it has a longer wavelength, then the scattering will be least. They are absorbed by the glass, but they are not absorbed by the rock salt. They do not affect an ordinary photographic film. Effect: small doses of infrared radiations are useful as they produce therapeutic effect on the human body. Heavy doses of infrared radiations are harmful as they burn skin and the living tissues of the human body. And these are the few uses. Infrared radiations are used for therapeutic purpose by doctors. During a war, infrared radiation are used as signals because they are not much absorbed in the medium. They are used in photography at night or in the midst of fog because they are not much scattered by mist or fog. They are used in the remote controllers. So this all I am just giving as a note, because you just you have to write in your exercise book and go through it. Similarly, for the topic ultraviolet radiation, you will be writing its source from your textbook. You can write its detection and properties, effect and uses also, right?